Hello, 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 Puro. Can you hear me? Hello, 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 Puro.
Hello?
Yeah. Shall we start?
Yeah, we can start.
What are we solving today?
Okay, I'll just send you like I need to know a couple. I have some doubts and some questions. And can you give me notes on something, or is that something you can do? Like if I were to give you like a topic, can you just give me like base notes, like all the notes related to the topic? Hello? Oh,
Yes, Puro.
yeah, yeah. I was wondering, could you give me the notes if I were to give you like a topic? Would you explain to me? Or like, would you
Oh,
require, do you need questions more, or can you just give me some notes on like topics?
whatever you want, wish for okay. I can. You want me? You want me to teach some topics? I will do that. If you want me to solve some problems, I will do
Okay, I can send you one couple questions, and then we can, if we have time, we can go on to topics. That's all right.
that. Okay.
Okay. Yeah. Let me just send it to you. Document. Okay. In this one, can you do the last question?
Uh, uh,
Uh,
he hasn't
yeah.
sent actually one.
I. Oh. Okay.
Have you already shared that one with me yesterday?
Um. No, I don't think I've shared this one with you.
Okay.
I just sent it to you though. I sent it to the same number that I've been.
Okay. He hasn't sent me yet.
And then also this one.
Uh, have you sent all those to him?
Yeah, I know I sent it to the number, like both of them, but I didn't get anything.
Yeah. Now I received it. Yes.
Oh, okay,
Uh,
okay. So
which one?
the first one, the first PDF that you got, can you do the last question?
Last question of the first PDF. One second.
Yep. And
Which
the
one? The
second PDF,
that one, right? Like a parachute one.
uh, yeah, that's the parachute one. Yep.
Yeah. The parasite. And what is the other one?
And the other one is question, I believe, four, let's see. Four, yeah. Question four.
Question four in the next PDF.
Yeah, the second it's called discussion six. That's what the PDF is called. So you can just check that out.
One
Question
second.
4 in that. I just need to know
Uh,
like the axial force. I'm kind of confused on all that. Like
the
axial shearing
okay.
and like what is the difference between axial force and shearing force and bending moment and like so on and so
Uh,
forth.
that one, right? Determine the internal stresses. That thing, right?
Yeah, internal forces. Yep, yeah, that's the one.
At a point Z of the structure. Okay, where is J here?
Yeah, I just don't know how to do certain questions like phrased in the same manner. So I just need notes based on what are axial forces and like how I can apply them and like
Okay.
yeah, anything like that.
So for this one, first of all, have to find no. We'll have to divide this. You can see this is a combination of two different frames, correct?
You just showing me on something or just telling?
Yeah. I started drawing. Can you see that?
No, I can't.
Oh, okay, okay. Let me share the screen. Yeah. Can you see that now?
Oh yeah, I can see it now.
Yeah. And you can see this is a frame. Like you have A, B, C, D is one frame, and C, E, F is another frame. They have been hinged at several points like C, D, and E. And the thing that you have to do is like you'll have to no, dis, you'll have to separate the individual frames and do the analysis. And you know, right? Like, and what is that to be found out? Determine the internal structures, sorry, internal forces at what are the various internal. We'll have to determine the axial force. We'll have to determine the shearing force and bending moment at point Z of the structure indicated. So
Yeah.
uh, l- let's uh, let's do this. Like uh, let's analyze this A, B, C, D frame. One second. So, can you give me 1 minute? Like it is.
Yeah.
Let this the low point. Yes. Now let I can see that. Let me analyze A, B, D. This A and there's B and we have C. At C we have range and there's D. This is B, this is E. And yeah, and both A and F are at the same line and respective lengths have been given. So see how is that you find the force. This you can find the better way of solving this would be finding the forces at D. Okay, if you can find the forces at D, there if I dismantle the frame uh, like take CEF one CEF would be one frame and DE, they have been linked through DE, and I can if I can take that away. So if I can find, you can see J is somewhere here in between C and D.
Yeah.
If I find the forces at D, right? What is shear? What would be the shear force at J? Shear force, and if I take the section at J like this,
Yeah.
and this becomes the right of the section, and this becomes the left of the section, um, and you can see what shear force at J would be what the summation of the algebraic summation of the forces either to right or left of the frame, right?
Yeah. Yep.
And if I think that there is no CEF frame, okay, if I take away CEF frame, then I'll have to what does it have to do? I'll have to replace with the reaction forces, correct?
Yeah. Yeah.
And I can see If I can somehow find the forces at D, then it's I can easily find the shear force, bending moment, and all the things at J, right?
Yes.
And first of all, so what is that they have done? Okay, they're asking for only this, right? Only the shear force and all that thing.
Yeah, at that point.
Yeah,
Point J. And what is axial force again? I just need a refresher, sort of.
the axial force, like this one's. 1 second. So if I let me draw this ABCD frame. So this is J, and think that so I'm drawing only ABCD frame. Okay.
So
A,
in such questions, you just separate the frames, right?
yeah,
First.
I've separated the frame. Okay. I've taken away the CEF thing and DE link. So if I take away that all those things, so I'll have to draw the forces. Let me call it as D in
But
y
isn't
direction.
the shear force, axial force, and bending moment at point J based on the two frames? So then how will you like join the equations together? Like how will you
Uh, uh, no, dismantling the frame. Okay, if I dismantle the frame, I'll be having two forces, right? I'll have to, whenever I dismantle the frame, I'll have to represent with the respective forces, correct? So this will
yeah,
be
yeah.
Cy, and this will be Cx, and it will be dy, and this will be dx. Okay, and now this is still joined. Okay, this is still joined.
Yeah.
Okay, and now now I can take a section, correct, at J, and you can see uh, there are only two forces to its right, correct? Dx and dy.
Yeah, yeah.
Yeah, and dy will cause shear force, and dx will call dl will cause axial force. Dx will cause axial force.
Sorry, what were you saying?
dy 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 will cause shear force at J, and dx is responsible for axial force at J.
What is the difference between the two forces?
No, dx, no, you can see dx is trying to pull the member, right? Pull the section
Yeah,
at no, uh,
outwards.
such a
Yeah.
force is called axial force. And if no, if a force is normal to the section, it's an axial force. If a force is parallel to the section, it's called shear force.
Okay, so that's how you define the two. The difference between the two is
Yeah,
axial forces are parallel to the section.
no, axial force is a force per normal to the section. Okay? It's not.
Axial force is normal to the section.
Yes, axial force is not correct. Dx is normal to the section, correct?
Normal to
This section,
BA, like
this section.
sorry. Yeah, yeah.
Sorry. This section, what I've drawn.
Yeah,
And you
yeah,
can see
got it.
dy is along the section, parallel to the section. Okay? It is trying to shear the section, not uh, uh, pull the section. Dx is trying to pull the section. It's normal to the section. Okay,
Yeah,
right?
yeah. And
Yeah.
okay.
And so if we can somehow find dx and dy, the problem is over. And you can see and dy will also cause moment at J, correct?
EY. Yeah, yeah.
Uh, that will cause a bending moment. Okay, so that means our main motive in this question should be solving for dy and dx. Okay?
Yeah, it will. DX won't cause any moment, but DY will, right?
Yeah, dx is simply passing through J. It will not cause any.
Yeah, yeah.
So let's find dy dx, and if we can find dy and dx, it's over.
You also need to find bending moment, right? Like,
The bending moment is what? The bending moment is what? Dy times 6 inch, correct? J,
yeah, pretty much.
correct? That's the bending moment. And,
Okay.
correct? So if you can find out dy dx, and yeah, that's uh it's over. So how is that we can find the dy and dx? You can see uh, we first of all we can solve for the whole frame. So that we'll be getting what? We can get the reactions at A and B. Okay. Let's take the whole frame. Okay. So this is a whole frame. Let's do the equilibrium of the whole frame. Okay.
Okay.
And you can see if I do the and at B there can be this by and bx, and at A there can be ay and ax, right?
Yeah. Yeah.
And now and this force at F is which is 60 pound force, and it's making an angle of theta. Is theta given? No, just simply say theta. Do we have to calculate theta? No.
And I mean, no, we don't have to, but I'm assuming you probably need to just because you need to find the X and Y directions, right? Like the X and Y components.
No, theta is not given, right?
It's not given, but I just thought you'd need to find it. Or I don't think, actually, no, never mind. You can probably just use it without theta.
No, in the solution they say theta equal to 0. Why? I don't know. You can see that.
Um, I don't
They
think
say,
this, yeah, I don't know why they say that, but I'm not entirely sure. Just do it the way you would do it, and that should be fine.
yeah. So if it is theta, let me call it as some theta, and you can see uh, I can divide this into respective components. This would be 60 sine theta, and this would be 60 cos theta. And you can see by plus ay should be equal to 60 cos theta, and ax plus bx should be equal to 60 sine theta. Correct?
Sorry, so you're just like summing up all the forces, right?
Yeah, all the normal forces, ay and by are upward forces, and that must be balanced by the downward 60 cos theta force, and ax and bx are towards right, and 60 sine theta is towards left. That must be
What
balanced.
about CY and DY? Why did you include that?
Yeah, we haven't yet dismantled the structure, right? So cy and cy will be internal forces. We don't have to consider that. Okay, if I had
Okay,
a
yeah,
dismantle,
that's what I'm kind of confused. Like, how do you make something an internal force, and what is an internal force, external force? Like, how do you
see
differentiate between the
now
two?
this see I have dismantled the structure at only and A and B. Okay, whenever so that's why I'm representing the reaction forces there. Okay, I haven't dismantled the member at C, E, and C and E. Okay,
Okay,
whenever you dismantle the structure from its frame, from its condition, then and only then you'll have to represent with the forces. Okay, and you can see in the second in the second diagram, I have dismantled CEF frame. Correct?
yeah.
That's why I'm representing the forces there. Got it?
Wait, say that again. Sorry, my bad. Say that
In
again.
the second one, I have separated both the frames. I have separated CEF from ABCD,
Yeah.
and so that's why I'm representing the forces. I'm indicating the forces at there at C and D.
Oh, okay, okay, okay.
In the first one, I have not done that. Okay, only I'm dismantling at A and B. Okay, that's why I'm representing forces at A and B only, the reaction forces.
So C and D are categorized as internal forces?
Yeah, whatever the forces that are there, they are internal to the structure. They are not no force is is acting externally on C and D, right?
Yeah, yeah, yeah. I mean, there are forces there, but
Yeah, there are
it's
no no for the combined frame there are no forces there. Correct. When you separate the frames, when you dismantle them, then we'll have to represent the forces there. Okay, and you can see, and you may ask me why is that I have represented ay and ax. The thing is, I should not have drawn this. Okay, I have dismantled the structure only at A and B. That's why I'm representing the forces there. And you can see if I can draw this, no, if I can draw this, there is also this, correct? The hinge thing and all.
yeah.
Now on the hinge, the forces will be something like this, the opposite of what I have drawn on the frame. Sorry.
Oh, okay. When the hinges are on, there are no forces there either, though. So in
Correct.
the combined frame,
Suppose,
the only force that there is 60 sine, the external.
yes,
Okay.
and you can see if I combine this one and this one, again there will no again there will be no forces. They get cancelled each other. Correct. They are opposite to each other.
Yeah.
No, no. Whenever I dismantle the frame only, then only the forces come into the picture. And when I attach it, the forces get cancelled. They
Mm.
become
So
intermittent.
in this case, you knowingly dismantled only the A and the B, so you can
Yes,
equate it to the force there, so that you don't have to deal with the extra variables of C and D.
exactly.
Okay.
You got it so far.
Yeah.
Yeah. Now, you understood these two equations. These are on the
Yeah.
only. Okay. Now let's take the moment about B or A, either of them. Okay. Let's take the moment at B. If I take the moment at B, there is one either or. Let if the moment is at A or B. Through B, we have three forces passing through B. Correct. By and Bx are obviously passing through B. Correct.
Yeah.
And Ay is also passing through B. Correct.
Um, Sorry.
This Ay.
A. Yeah, it's passing through. Yep.
So, and even that can't create any moment. Correct.
Yeah.
And now, let's and you can see whatever the moment and what are all the forces that are creating moment about B. Then ax can create moment, and 60 sine theta can create moment, and 60 cos theta can create moment, right?
Mm.
Now, what is the moment created by 60 cos theta about B? It's clockwise, right?
Um.
No,
One second.
just make this as a center. Just make this a center and try to rotate the frame, the 60 cos theta about that point B.
Yeah. No. It's clockwise. Yep, you're right.
It's clockwise. And what is the distance? The distance is this AF, correct?
Oh yeah, A to F. Yep.
ATF. And what is the distance? You can see 4 inch plus 12 inch plus 4 inch. That would be 20 inches, correct?
Yeah.
And what is, and let me write that. And that's clockwise. So clockwise moment is 60 cos theta multiplied by 20 inch, correct? And you can see AX is also creating moment about B, and that will be equal to AX times 8 inch.
The X times uh wait, you're calculating the moment from at what point exactly? At B?
About B moment, I'm taking
About
moment
B.
about
So that
point.
will if AX is times like 8, I'd say.
Yeah, AX multiplied by 8, correct?
Yep.
And that would be counterclockwise. AX multiplied by 8. And also,
Mm.
uh, 60 sine theta is also creating moment, and that is again clockwise about B.
Wait, AY is not creating a um
AY can't create any moment because it simply passes through A. Okay, AX can create moment.
oh yeah, it passes through B, so it can't. Yep, you're right. Yeah.
AX can create moment. AX can create. That is
No, I'm saying
AX.
AY is passing through B, so it
Yeah,
can't.
it can't, but AX can create, which is AX into 8.
Okay.
Okay. And what's the moment created by 60 sine theta? It's again clockwise. It would be 60 sine theta into 8 again.
Yeah, it's 60 signed into 8, yeah.
That I'll have to multiply here. Sir, I'll have to add here because the moment created by both 60 cos theta and 60 sine theta have same sense.
Yeah. Is if it's clockwise, it's a negative, like that's the sign convention I'm used to.
You can see, you can follow whatever
I mean,
I'm
you're
using.
doing the
Just,
opposite. Yeah, you're doing the
yeah,
opposite. You can the same thing.
just whenever you are taking moment, you follow this. Okay, just whenever you're taking a moment about something, you do
Uh-huh.
this. You write down all the clockwise moments, all the forces that are creating clockwise moment. You write down all the forces that are creating anti-clockwise moment and add, equate them. That's it.
Okay, doesn't matter about the sense exactly.
Now it doesn't matter about the signs, correct? Clockwise and anti-clockwise movements must be
Okay,
balanced.
because regardless, it'll get cancelled out or whatever.
Yeah. So see, these are 60 sine theta and 60 cos theta. They were creating clockwise moment about A, and whereas AX was creating anti-clockwise moment, and they must be balanced.
Okay.
So, and you can see from this, so this is one equation. And if had they given theta, this would I could have calculated AX. So you can see the only equation.
I
I
think
could,
yeah, but I'm just saying you could probably just calculate. Um, couldn't you just do 60 cos theta and then put it in the previous equation and then just calculate from there?
sorry.
Like if you go down,
Yeah.
um, you can write this equation in terms of 60 cos theta and 60 sin theta, and then okay, no, never mind. That wouldn't make any sense.
So
That would be too many variables.
so we have three equations. We so far have three equations, and two unknowns
You can
can be
assume,
constant.
you can probably assume it's zero. It's fine. I think it doesn't matter. I think if he says it's zero, it's zero. Like,
Yeah, I don't know why.
yeah, I don't know why they didn't include that. So you can just write theta is zero. It's fine.
Yeah, if theta is zero, uh,
Yeah.
uh, sorry, shall I take theta to be zero?
Yeah, sure. You can take theta as zero.
Theta is zero, then this sine zero becomes zero, and ax becomes minus bx.
Yeah.
And from this, from the second equation, from this equation, this becomes zero, and from this ax becomes 60 cos 0 is 1, 60 into 20 by 8. So this becomes ax becomes 60 into 20 by 8.
Yeah.
So this would be ax, and minus of ax would be bx from this equation. And we have
Yeah.
one more, and from this by plus ay is equal to cos 60 cos 0, and this becomes 60.
Yeah.
And yeah, so we so far have found out how many forces. So two, we have found out two forces, uh, but ay and by are still unknown. We need one more equation actually. We need one more equation to find out by. The moment taken about a, they have taken moment about, yeah, see bx b. So how is that we can so we have four unknowns, right? We have four unknowns, but we do have only three equations here. uh, can I get anything if I take moment about b? Sorry, if I take moment about a, so b, I'll not be having anything. I can get bx, but bx I've already got it, which is minus times ax.
Why
So
don't you take a moment about F?
if I take moment about f, uh, taking moment about f is of no use actually. uh, yeah. So yeah, I can take moment about f. Let me take moment about f. So if I take moment about f, so what are the forces that can create moment about f? Ay can create moment, by can create moment, and bx can also create moment. One moment, right?
Yeah, everything can create moment.
No, ax can't create any moment because ax
Oh no,
passes through.
AX can't, but BX, BY, and AY can.
Yeah, bx, by, and ay can. So uh, and you can see by and bx. Sorry, everything is, everything about f is clockwise, correct? No, yeah, I got it. Since you can see ax is minus of bx, correct, from this
Yeah.
equation, and that means bx must have acted like this,
Why don't
correct?
you just do like the Fibonacci diagram for ABD? and then include all the internal moments, and then just do the summation of all the x forces and the y forces, and then that should give you two more equations, right?
For ABD thing, okay, if I can't do for ABD thing because I'll be having two more unknowns. Like I'll get so many unknowns if I just do for ABD. I'll also get CY, CX, DY, DX. Correct.
Yeah, okay. What do we need to find right now? AY?
See, we so far have found out two unknowns, AX and BX. Okay.
Yeah.
And if I take just like what you said, if I take moment about F, if I take moment about F, I may get one more equation. So this is one more equation actually in terms of BY and AY. If I take moment about F, you can see BY and AY are in same sense. So the moment created by AY about F would be AY into 12, and the same would be with BY into, sorry, what's the 20, sorry, 20 inch. It's at a distance of 20 inches. So AY into 20 plus by into 20, that must be balanced by bx times, and bx is at a distance of 8 inch from us. So this is one more equation, correct?
Sorry, can you go up again? How do you do that? BAY times. Okay, I
This,
got 20.
yeah,
Then you did, because that's what clockwise moment, okay.
and
Then you did BY times 20 again, because that's clockwise again. And then you did BX times 8, because that is also clockwise too.
no. Bx is not clockwise because you can see the directions of ax and bx are reverse. If ax is in this direction, bx should be in this direction. You can see the sense minus bx.
Oh, why is it in the opposite direction?
See, from this equation we got that, right?
Oh,
A,
yeah. Yeah. Understandable. Yeah.
okay, that the direction of bx must be changed with the help of this
Oh, okay,
equation.
so it's negative. Yep, got it.
So bx into 8, correct? That's one equation,
So how does
correct?
this help us in terms of point J exactly?
So yeah, so uh, see with this what happens, you know. So we so you see if through all this we can find ax, bx, ay, by, right?
Yeah.
Doing all this will give us ax, bx, ay, by, and then you can go to the second frame. Got it? Like,
1 second. Sum of. Can you
hello,
go down 1 second? Yeah.
sorry, should I
I
repeat
just want to
again?
see that. I just want to see the last equation that you wrote.
Yeah, this one. See,
Yeah.
ay and by are in the same sense. The moments created by ay and by are in the same sense,
Okay. Yeah.
and they are at a distance of 20 inches from f,
Yeah.
and that's why I multiplied ay into 20, by into 20, and bx is
No,
an
no, yeah, I
opposite.
got that.
So this is
Yeah,
one
I got that.
equation. So this is one equation, and you can see, so ay plus by should be equal to bx into 8 by 20, bx into 8 by
Yeah,
20.
but AY plus BY is also 60. So then you can just, oh, I see what you did.
See, it doesn't give us anything actually. The taking moment about b is useless. No, it will give the same thing again. It will give the same,
Oh,
correct? So that's why I'm not taken.
yeah.
I haven't taken moment about it. So the thing is, no, you can use. See, it's a 2D problem, right? It's a two-dimensional problem. You have used the force balance in x direction. You have used the force balance in y direction, and you have taken moment about one of the points, which is, see, what is the moment that we have taken about? We have taken about b. That's it. Then that means you have used all the equilibrium conditions. Okay. You even though you take the moment about any other point, you'll end up with the same equation again. You got?
Okay. Yeah.
Correct. So we basically used all the equilibrium conditions for a 2D problem. Correct. It's on a, every force is in one plane. So you have used the force balance in one direction. You have used the force balance in other direction, and you have taken moment about one of the points. So basically you have used up all the equilibrium conditions. Even though you take the moment about any other point, you will end up with the same equation again. Okay.
Okay. Yep.
So that means if we can't take the moment about, so taking moment about any other point will not give us anything. Okay. So how is that? That's the thing I was looking for. How is that we can solve for the other two? That was my problem. So okay, let's once go through this one. Let's go to suppose we have only we don't know we don't know about AY and BY, right? But we know about AX and BX. So yeah, that's the thing. You got it right. So we have 4 unknowns, but we only have 3 equations.
Okay.
So we'll have to find one more equation again. We have somehow have to find one more equation. So which one would give us the fourth equation?
D.
Sorry.
Or like, I'm not sure actually. Maybe C. A, B, F is gone. Maybe D.
Maybe
Or why don't you take based on section J, like just a random section from that point.
one second. One second. Let me once go through the solution.
Yeah.
So they have done the force balance in y direction. Basically, that was. And why is that they have eliminated AY? Can you see that? Can you see that they have just
Yeah,
eliminated
I
random?
just saw that. I just saw that.
Why is that? Is it
Oh, because that's a different kind of pin over there, I think. That's why. It's not like the pin at B where it's
okay? Is it a roller?
blocking.
Is it a roller thing?
Uh, I think I'm not sure, but it doesn't look like your average pin. It doesn't look like the pin at B. It looks like a different pin.
Oh, maybe that should have been a roller thing. Okay.
Yeah, yeah.
So if that is a roller thing, then we can no. You can see one force gets eliminated. Obviously, correct. AY there can't be any AY. Correct. Roller can't resist the moment in y direction, right?
Yeah, it has to move up and down, right?
Yeah. It can't resist the moment in y direction. It will simply allow the moment. So it can't resist. So there won't be AY. So if there is no AY, we can simply find BY, right? BY simply becomes 60 cos theta.
Oh, okay, okay.
So
That's a
that's
roller pin. Okay.
yeah. I thought that's even that is also a pinned joint. Okay? No, even if that is also a hinged joint, this problem can't be solved. Okay, because
Okay.
you know right, 4 equations can't be solved with 3 equilibrium conditions. Correct? We need at
Yeah,
least
yeah,
4
you can.
equations
You
to
need
solve for
four.
4.
Yeah.
Correct? So in that case, if the support at AY is a roller thing, then AY can be eliminated and BY simply becomes 60. This becomes 0 and
Yeah, yeah.
BY simply becomes 60 LBF.
Okay, got
But
it.
but so that's what I was looking for. And
Yeah, yeah, yeah.
now this becomes a simple problem. Okay, so let me also once let me bring my calculator. What is this 60 into a? I'm calculating AX 60 into 20 divided by 8. So AX is 150. Okay, AX is 150 LBF. This is AX. And what is BX? So BX will be minus of AX. So that will be minus 150, or you can just reverse the direction of. Okay. So now let's go to this individual frame. Okay. Now let's discuss.
Uh,
So we don't have
AB.
AY. We have
Okay.
AX. We have BX. That is up. They should be in opposite direction because AX is minus of BX, and we have BY, and we have dismantled it. We can have CY, and we can also have CX. There is Z somewhere here, and at
Oh, you
D,
completely dismantled it.
yeah, I've dismantled the frame. both the frame. This is dy and this becomes dx. Okay. So
Okay. So first you find the separate forces and then you
yeah.
do it in terms of
Now,
section J.
now I have initially I took the equilibrium conditions for the whole frame. Okay. For the whole frame,
Okay.
just I have dismantled the joints at A and B. Okay. For the initially. Now I'll also dismantle the frame, other frame C, D, and E. Okay. Sorry, C, E, F frame. Okay. If I dismantle C, E, F, then I'll also then when I will separate them, I'll have to represent the forces there. Okay. And for your if you are confused, so the free body diagram of the other plane looks something like this. Okay. I'll so that for the sake of idea. So this is E and this is the other frame. Okay. And now you can see at D, I've taken dy and dx like this. Now I'll have to take like this dy and dx. And this will be cy and cx. Cy and cx. And there is a force of 60 lb at f. Okay. This is a free body diagram of the other frame.
But the theta is 0, so isn't it directly
Yeah.
downwards?
Okay. This will be 60 lb. Got it?
Yeah,
Now
yeah,
you
got
now
it.
think that if I join both the frames, you can see the forces are opposite to each other. They get cancelled, correct?
Yeah.
And they become internal. Got it?
Yeah, so the forces that are opposite become internal?
You can see. So on ABCD frame, dy is in dy is in plus y direction. You can see on CEF frame, dy is in downward direction. Correct. When I join, they get cancelled at that point.
Yeah.
So, and when I join both the frames, the forces get cancelled and they become internal. Okay.
Yeah, got it.
Okay. That's how the free body diagram of the respective frames look like.
Okay.
Now, now let's this is the ABCD frame and this is the CEF frame. This is CEF frame. Now let's do the force balance and moment balance for ABCD frame. Okay, you can see what are all the forces in positive direction. uh, by
Um, yeah.
by plus cy plus dy must be equal to 0. Correct.
So
By
are you just equating all the forces in the y and x direction and everything?
now I'm doing the force balance for a y direction. Okay, for
Okay,
y.
sorry, yeah.
If I do the force balance for y direction, you can see
So by plus
I've taken by in positive direction, and cy and dy are in also positive direction. No, after you solve for that, you will get some of the forces as minus. Okay, obviously, no, all the forces in upward direction will not yield the equilibrium condition, right? Some of them, one of the forces at C and D may be in downward direction. Okay,
yeah.
I don't know which one is downward direction so far, but for that I'll take this just by plus cy plus dy. Let it be 0. Okay, because no force is in downward direction, right?
I mean 60 lbf, but that's in a different frame.
Oh
But
yeah,
okay, yeah.
yeah, that's in different frame. That won't count here. That doesn't count here. Okay.
Okay.
Huh? And also this is one equilibrium condition. This is summation of forces in y direction must be equal to 0. Correct.
Yeah.
And let's do the force balance in x direction. You can see ax, cx, dx are in one direction, bx is in the other direction. Correct.
I mean in frame one, dx is in the same direction. Oh, okay, bx. Yeah.
You can see that in that case, ax plus cx plus dx must be equal to bx.
Yeah.
This is one equation. And we can also take let's do this one, moment balance about point B. Okay.
Yeah.
Getting it? If I take moment balance about point B, you can see the moment created. What is the moment created by Cy? Cy
Moment
into
created by CY in the first
about
frame.
B in the first frame. No, I'm talking about only first frame. Okay, all the
Oh,
equations that
okay.
I'm writing for ABCD. This is A.
CY about B is counterclockwise.
Cy about B is counterclockwise, and dy about B is also counterclockwise. The force about A about sorry, the moment by Ax about B is also counterclockwise, correct?
Yeah, yeah.
And you can see, yeah, let's do the moment balance. Ax into 8 must plus Cy into 4 plus dy into 16 must be equal to 0. One, you can check it. So this distance is given as 16 inch, and this distance is given as 4 inch, and this distance is given as 8 inch.
Okay, what is the point of J here? I don't get that. Like, why do we have that point? What do we do with that point? Like, that's the point we need to calculate everything on.
Yeah,
So,
that's the point about which we are to calculate. For that, but I initially told you, right? If we can somehow find dy and dx, then we can find all the things at there. Correct? If I take
oh, okay, okay, yeah, yeah, yeah.
so my intention is to find dy and dx now. Okay.
Okay, okay, got it, got it.
So just leave j. Okay. For now, just leave j.
Yeah, yeah,
Yeah. And let's talk about just you got it right. The moment equation about this point.
yeah.
Yes. And you can see how many unknowns do we have. We again have 4 unknowns, like, and we used up. So do we have ax, correct? We have ax,
And we also have,
sorry,
I think
sorry.
no, never mind. Yeah, we have BY as well, so then we can do two different. Yeah,
Mm,
because we have these two equations. We have BY, which is 60, so we can move it to the other side. So CY plus DY is equal to 60, and then we can just do simultaneous equation right from there with 1 and 3 to find CY and DY.
yeah, 1 and 3, yeah. From 1 and 3 we can find these two. Yeah.
Yeah, yeah.
And yeah, let's do this. Okay. Yeah, we have this equation, correct? So from 1 and 2, what is that I can use here? So let's take this from 1. What is that I can write? Cy plus dy is equal to minus dy.
Yeah, yeah, which is
And from
minus
this,
DY is 60, as you said before.
and from this I can say, from equation 3, Cy plus I'm taking 4 as common. 4 dy must be equal to minus 2ax, correct? If I take 4 as common,
Minus, wait, isn't it times 8 or 2?
yeah, I'm taking 4 as common. This 8 becomes 2 times 4, and this becomes 4 times 4, 16. So 4
Oh,
can be
okay.
taken common, okay, and equated to 0. And this is what I get, correct? These are the two equations that I get, correct?
Yeah, you do get those.
Yeah. And let us subtract equation 3 from equation 1. So this cy gets cancelled. From this I can get uh, 3 times dy should be equal to minus 2ax plus by.
Yeah.
And we have from dy, I have this minus 2 times ax plus by by 3. And what is that we have for ax? What is that we have for ax? Ax is 150. So we already calculated this. Minus 2 into 150. And for by, I think we have 60. That is 60 by 3. And what would be this? This is minus 300 plus 60 by 3. And minus 300 plus 60 might be minus 240 by 3. And this would be minus 80.
Yeah,
correct?
so yeah.
And
And
you can
then
see
CY
we
would
are getting
be
a minus. One thing, we are getting a minus sign, right?
yeah.
That means I'll have to reverse the direction of dy.
Like you said before.
Yeah. So if I no, let's just take the no. Initially, you don't whenever you are not sure about that sign, you can take it one direction. If the answer comes out to be negative, then you will have to reverse the direction. Okay.
Yeah, yeah.
So now this will be the direction of dy. And let's talk what is cy from this. You can see
20.
from the first equation dy is sorry from the first equation cy is minus by minus dy, correct?
Yeah, so it's 20.
uh, 1 second. And by is 60, and what is minus dy? Minus dy is plus 80, so it would be 20, like you said.
Yeah.
So and since you are getting the same direction, which is positive, correct? And that means you don't have to reverse the direction of cy.
Yeah.
And so that will be this. And what about cx and dx? So we can
Uh
find cx and dx like this. You can see for that. Uh, so we so far have found out cy and dy, right?
yeah.
And so we are yet to find where we are still we should still find cx and dx. And you can see in this abcd frame we had four unknowns, right? Cx,
Yeah.
dx, cy and dy. That can't be found out with three equations, correct?
Yes.
And for that we'll have to take the help of the fbd of the other frame. Okay.
Yeah, yeah.
You can see we also have one more frame, cef frame.
Yeah, yeah.
And in the cef frame, if I take the force balance in x direction, you can see cx plus bx, sorry, cx plus dx should be equal to 0.
Yeah, yes.
And that means cx should be the negative of dx.
Yeah.
That will let's use this here. Okay.
Yeah, I got it.
Oh, sorry. If cx is negative of dx, 1 second. Okay, and that means they get cancelled actually. They get cancelled. Yeah. Okay, okay, okay. Mm, cx is negative of dx. That's understood. But 1 second. Mm, you, did you understand it so far?
Yeah, I've
Uh,
understood so far. Yeah.
yeah. So we still have one more frame like this. See the thing for this frame, we have one more small frame which is a DE. Can you see? The those two frames have been linked
Mhm.
to ED, correct?
Yeah, yeah, yeah.
Yeah. And you can see the thing for this ED frame is whenever we have a two force, uh, see, the thing is in this two force in this member, the force should be only along this direction. Okay. So this is a single structure. So that's one thing that you'll have to remember. Okay. So whenever we have a single force, single member, okay, the force will be along the member. Okay.
Yeah.
Uh, See, for this to stay in
So when
equilibrium,
you have like a single line like this, like a single metal rod with D and D, the force will be on either sides.
yeah, that and we will not have any force like this. So what if
okay.
so, okay, let me talk about this DE frame. Okay, I just dismantled DE. Okay, let me just dismantle DE. So if I just dismantle DE, what is that I have to represent? I'll have to represent EY, EX, and DY and DX, correct?
Wait, sorry, 1 second.
I've taken just that DE, that small DE one. Okay,
Sorry, what did you do?
that small DE pin is there, correct? That is connecting both the
Yeah,
pins.
yeah, yeah,
I've
yeah.
taken just that one. Okay, just that one.
Okay.
So when I just dismantle that out of the frame, I'll have to represent every force that is acting there, correct?
Yeah.
And you can see, and if we have such a member, will not have DE and DX. Why is that we don't have DE and DX? Is you can see if there are EX and DX, if there are EX and DX, if I take moment about E, so let me take moment about E, okay,
Yeah.
and let this distance be some K, okay, let this distance be some, the distance between the length of that frame be some K. What is the moment created by what is the which force can create moment about E?
DX.
Only DX, right?
Yeah.
And what would be the moment? Moment created about E is DX into K
Anti-clockwise. Yeah, DX into
and
K.
clockwise. And there is no force, there is no moment acting at E to counter this. Correct? Then in that case, that DE link must be rotating. Correct. There is some net moment there, correct?
Yeah.
Then and if there is some net moment, that DE must rotate, but it is not rotating. Correct. It's stationary, right?
Wait, why is it stationary?
For it to be stationary, the only way is DX should become 0.
Wait. Why is that happening? Why doesn't it rotate? Because as it is, DX is acting times K, so there should be a moment there, right?
Yeah, but in general, when you look at the frame, is it rotating? Is DE rotating? No, right? D is
No.
a, no. Then
Yeah,
if
when
it
you
is
look at
not,
the entire frame, D doesn't rotate.
D is not rotating, then for DE not to rotate, DX should be 0, correct? There is no other way,
Yeah.
correct? So this is how,
Oh, okay. Got it. Yep,
got it.
yep, yeah.
That means you can consider whenever you have single structure like this, you will not be having forces in x direction. Okay, you'll only have forces in y direction. That means if dx is also 0, ex should also be 0, correct?
Yeah, got it.
The other way of countering it, if I take the moment about d, then only ex can create moment about d, correct?
Yeah.
And again the same thing, the this link d is not rotating about d, and in that case ex should also become 0.
Okay, got it. Yep.
In that case, whenever you have single pin structure like this, then you will have only forces in this direction. Okay,
Yeah. Yes.
single straight member like this. Okay, that means
Yeah.
dx should be 0. So from this we get dx as 0. If dx is 0, cx should also become 0, because cx plus dx was 0.
Wait, sorry, go up again. Isn't DX 0? So isn't that DY, not
dy
DX?
will be there, dx is 0, dx is 0. We
So it's
conclude
EY and DY, right?
ey and dy will still be there, ey and dy will still be there.
So then, oh, okay. I got it. Yeah, I got it. Okay. DX is 0. Yeah, okay.
If dx is 0, then we have this
Then
equation,
CX is also 0. Yeah.
dx is 0, and so then that we will be getting this anyway. And the thing is, we concluded that dx is 0 and cx is also 0. So dx and cx are 0. And now let's come to z. Now we have found out everything. Dx is 0. So dx is 0. Now take a section at z. Sorry. Now take a section at z. Now what would be the shear force at this section? Now if I take a section at j, this will become the right of j, and this will become the left of j. And what what is the shear force at J? Shear force, you know the direction, the algebraic summation of all the forces either to its right or left. And if I solve for shear force at this section J using the right part of the section, I only have one force to its right, which is dy.
Yeah.
And what would be the shear force at this? That would be, and if that would be dy. Shear force
Yeah.
at J, shear
And
force
that's
at J.
positive, right?
And so what is yeah, if we are solving from the right part, that would be positive dy. Okay.
Yeah.
And that's one thing found out. And what would be the moment? What would be the moment at J? Bending moment at
Moment
J. The
at
bending moment at J dy times 6 inch. Again the same thing. Again the same
yeah,
thing. No,
no, yeah, no, I got it, I got it. I'm just like writing it down. Yeah.
I'm finding the bending moment using the right part of the section. I only have one force that can create moment at J, which is dy, and that would be equal to dy times 6. Okay.
Yeah. Shear
And
force is just dy, right? Which is
yeah,
positive, and then
yeah,
bending moment is dy times 6.
yeah. Bending moment will be dy times 6 plus it would dy times 6. Okay. And what is the axial force?
0,
Axial force dx should be zx, but dx is 0.
0. So
Yeah. That's how we find out shear force, bending moment, and axial force at J. Okay.
is that it? Or there must be more, right?
No, no, no. That thing. We have found out axial force, shearing force, and bending moment. The three things they are
According to
asking.
this, I mean, in the one sec,
Uh,
bending
they, they
moment
have they
is
have found out using the, you can see axial force is 0, correct? Can you see from the final answer, final three steps of the question?
yeah, F is the axial force, right? So that's 0.
0. And what is V? V is shear force. And
E
but in our case dy, that is dy. What is dy that we got? Which is 80.
dy that we got, yeah, that's 80. It's
Uh, you,
negative 80. So
uh,
that's 80.
yeah, we are, since we are solving for the right section, since we are solving for the right part,
Oh,
that would be
yeah.
positive, correct? You can see that is 80. And the thing, in this question, in your answer, they are solving using the right part, left part of the section. Okay.
Yeah.
The reason why I've taken the right part, because I had only one force to its right, correct? That would be simple.
It's easier that way, you're right. Yeah.
We are still getting the same answers, right?
Yep.
And what is the moment created? Moment created by would be dy into 6, correct? From our part, from our solution.
Yeah, dy into 6, yeah, you're right.
Dy is 80. 86 is 480. So even your
Yeah,
answer is
yeah,
also.
so it's right. Yeah, it's correct. Yep.
So that's the reason why I've taken the right part, and that's the reason why I'm so much interested in finding dy and dx. Okay, because I have only two forces, right? So I won't be bothering about cy, by, cx, ay, and all those things what's left.
Okay. Okay.
You can still
The
yeah.
formula that I'm so confused. What is the formula that they used in the what is V in that? I'm kind of confused there.
We no that okay. So they are solving
Oh,
using the right,
actually, that's shear force. So they're
yeah,
using.
TFOs, and they're solving using the right part. Okay, sorry, they're solving using the left of the section. Okay,
Oh,
so
yeah, yeah. So they broke it at
yeah,
that part, and then yeah.
using
See,
the
so that's so my doubt is, even my professor, he breaks a section, and then he draws directions for the moment, the axial and the shear. So how do I draw the moment for the axial and the shear? Like, how do I draw those directions? Like, what is the idea logic behind drawing those directions? See,
see.
and he broke it at J, and he took the left side, right? That's what you can see
He
from
took the
there.
left. Yeah, he took the left side, and suppose think that we are solving for shear force using the left of the section. And what are all the forces? What are all the upward forces to its left? To its left. So only upward forces can create shear force at J, correct?
Yeah,
And what are the upward forces that are there here? By and cy, correct?
yeah.
And you can see since we are solving using the left part, all the upward forces will be taken as positive,
Yeah.
and that, yeah, shear force will be by plus cy. That's it.
No. Like it's just I understand the logic. It's just what is the directions I should like see if you I don't know if you see, but if you see the example, right? He's written F towards the right. He's written the moment, and he's written the axial force and the shear force, right? He does that for every question, like where he like writes the diagram and he writes the forces like that on
Okay,
that
okay.
section.
Yeah.
Then
So I got
how
that.
do I intuitively write those diagrams? Because this is, yeah, that's how he does it.
So that the thing is, he breaks the section at Z. Okay.
Yeah, he breaks. That's what I'm trying to tell you. Yeah, he
Whenever,
breaks it, and then he draws forces on that end. So,
yeah,
and then
that that
the thing is, I understand where he's drawn the forces, but the direction of the forces is what matters in that case, because that's what makes it.
okay.
Like, that's
You
what
can
gives
see
you the right answer.
at Z has broken the section. Okay.
Yeah, he broke right J right
And
before J.
and he is taking the left part to solve for the answers. Okay.
Yes.
So we
Yes.
have by like this, and we also have cy like this. You can see, if I break, now we also have bx and ax, right?
Yeah.
And you can see, yeah, I have broken the section. I have broken the section at z. You can see by and cy are in positive direction, positive y direction, correct?
Yeah.
The only way this frame can be in equilibrium, if and only if there is some force acting in downward direction at z when I break it.
Yeah, there has to be okay.
That becomes your shear force.
Wait, sorry. So when you break it, you need to be opposing the two forces going
Yeah,
upwards, right?
yeah. Then only it will be in equilibrium, right?
So when you do such a question, you think of actually breaking that bit, and then you see where, like,
Sorry.
that's the idea. Like you
Yeah.
physically,
You
like you
see,
mentally break it.
first of all, you'll be breaking. Okay, you'll be
Yeah,
breaking it, and you calculate. Suppose in this question, suppose think that, suppose no, don't forget about your question. Suppose think that by is in upward direction and cy is in downward direction. Okay,
yeah,
and the value, let the value of b be some 60, and let the value of cy be 80. Okay.
yeah.
Now, what is the net force on this section because of by and cy?
It's downwards,
Ah,
like 80 minus 60, so 20.
net force of 20 in downward direction, correct?
Yeah,
Then for this frame to be in equilibrium, there should be a shear force of plus 20 in positive direction, correct?
yes.
So
Oh, okay,
that's how we decide directions. Okay.
okay, understandable. Yeah. And then
But
how does he do axial and bending? Like, which
axial and
direction
bending.
does he take that in? Yeah.
Let me. Okay. You understood the shear force direction?
Yeah, understood that.
Yeah. So by and dy were opposed in positive direction. To oppose that, there should be a net force of shear force in downward direction. So that is v.
Oh, and
Now,
from section J, the only forces that act in the section J to there's a Y component, those are only forces that are acting that can create a bending moment that goes in the anti-clockwise direction.
yes,
So the
yes.
bending moment will be in the anti-clockwise,
Yeah,
and the axial force would be parallel to the x and the two x's, so that would just be straight out of the broken piece.
yes, you're right.
Okay, got it, yeah.
So that's how this fj and m
That's how
works.
he thought about it. So you got to take the forces from the section J and then you got to draw the directions based on section J
Yes,
and breaking it. Okay, fine.
yes. So that's how it works. And yeah, and one more thing that you need to consider is this one. Okay, whenever we have a single pin structure, we will not be having forces in x direction. Okay, they become zero, and
Yeah, I got it.
that's how we got dx and ex to be zero.
Yeah, okay.
So and better solve it using right part of the section. Okay, so that you don't have to deal with so many forces.
Yeah, it seems easier. It's much easier.
Correct. So if we solve using left part forces, actually you have ax, bx, ay, cy, and all.
Yeah,
So
it's too much.
to its right, anyway dx is becoming zero. You only have only one force, which is dy. So shear force becomes plus dy, moment becomes dy into 6, and axial force is dx, which is 0.
Yeah.
So this is how this works. Okay. So first of all, what is that you have to do is you'll have to find the equilibrium for the combined frame and find out the reactions at ay, by, cy, and dx, and then dismantle the frame. Okay.
Yeah, okay, okay.
That's how you proceed. And while dismantling, there is a structure de, because it's a single pin, there won't be any dx and no, there won't be any forces in extension. You understood the reason why, correct? If there is any forces in if there are any forces, but the pin should be rotating, but pin is not rotating, so that's the logic behind it. That's how dx becomes 0. Okay.
Okay, okay.
So yes, any other thing, anything else?
Yeah, I sent you the other question, but if you don't have time, you can just send me the worked out answer or how you did
uh,
it.
Shall I do that? Okay, I'll
Yeah,
like
can you just do that?
handwritten solution. I'll get. Okay, I'll write it down.
Also, like
Okay.
the next class, yeah, the next class, can we do it next week? Like I need a because the week after I have an exam. So like if I have any questions, I can just ask you right before my exam, so you can just get it done with.
Okay. Okay. The one thing, no, you note down all the doubts that you have, and you can simply ask me.
Yeah, can
Yeah.
we do it next week then? Because the exam is the week after the next week. So it's on December 5th.
Okay. 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 Uh,
So then that
you
way I
can.
can at least study this weekend and I can talk to you like next weekend.
Okay. Okay. That's good.
That's fine with you?
Yeah. Yeah. That's good. We'll do it on same next week, Tuesday.
Yeah, next Tuesday should be good, yeah.
Yeah. So meanwhile, you'll keep practicing and note down all the doubts that you have. We'll solve it.
Okay, okay. Are you gonna do the second bit and send it to me, or can we just do it now? Like, is that a problem?
I'll send it. Okay, I'll send you in another 20-15 minutes. Okay, I have some work. After that I'll send it.
Okay, okay, fine. All right, all
Uh,
right.
me, I'll send you this now, right now, so that
Okay,
you
yeah,
can.
you can send me that. Yeah.
Okay, bye. We'll meet
Bye.
next.
Thank you very much.